Hello and welcome to this webinar on the exciting new features in nRF Connect SDK version 1.4.0. My name is Bjørn. I'm a product marketing engineer and I'm one of the three hosts today in this webinar. One of the other hosts is Krzysztof and we also have Joakim, and they're both technical product managers. Krzysztof is a product manager for short-range wireless, and Joakim focuses on cellular IoT. Just some quick practicalities. The duration will be roughly 45 minutes, and then we'll have a 15-minute Q&A. Questions are naturally encouraged, and please type your questions in the top right sidebar. So it should look something like this. All of the questions are anonymous, and please try to keep them relevant to the topic. And we will have a 15-minute Q&A at the end, which is when we'll answer most of the questions. The chat is not anonymous, and it should not be used for questions. If you have any questions, if your question wasn't answered, for example, if you have any more questions after the webinar, feel free to go to devzone.nordicsemi.com. We have roughly 30 or so application engineers there that are eager to answer any questions. Also, a recording of the webinar will be available together with the presentation at webinars.nordicsemi.com. So, just a quick content. So I'll give a quick 15-minute intro to the nRF Connect SDK and some basic terminology. Then I'll hand it over to Krzysztof, who will go through some of the short-range updates in version 1.4 of nRF Connect SDK. And then Joakim will finish off with some cellular IoT updates in version 1.4. And last but not least, we'll have a 15-minute Q&A. So this is just a quick show you the nRF Connect platform. So it does consist of the nRF Connect SDK, nRF Connect for desktop, nRF Connect for cloud, and mobile applications. So this is essentially a set of development tools to make it quicker for you to develop your product and get to market. Today, we'll only focus on nRF Connect SDK. So just a quick intro. The nRF Connect SDK is one codebase and toolchain for the nRF52, nRF53, and nRF91 series. It is optional for the nRF52 series, and I'll go into more details on that in a later slide. We do now actually have production support for the nRF52 and the nRF91 series in nRF Connect SDK. So that's great news from our side. And there is development support for the nRF52 series in the version 1.3 tag and later tags. And I'll explain a bit in detail later what production versus development support means. So some of the protocols we support, we do support Bluetooth Low Energy, Bluetooth Mesh, Thread, Zigbee, and also LTM and Narrowband IoT. Bluetooth 5.1 and Bluetooth 5.2 support are in development. So 5.1, that is direction finding, and Bluetooth 5.2 is Bluetooth Low Energy Audio. And the nRF Connect SDK does include the Zephyr RTOS. So this is from the Zephyr project. It is independently governed by the Linux project, and it's also designed and built for low-power embedded applications. So it is essentially a scalable RTOS, and it does have support for memory-constrained devices, so something, for example, less than 8 kilobytes, all the way up to large memory, high processing power devices. And it also does have support for the major protocols, so that could include UDP, TCP, CoAP, Bluetooth Low Energy, MQTT, HTTPS, just to mention a few of them. So just a quick intro to the code base. So here on the right-hand side, you can see all of the different layers. So it does contain the app code, also some connectivity protocols, wireless stack, and peripheral drivers. The code is organized into 4 main repositories. So in the blue on the figure on the right, you can see the blue. Those are the sort of the Nordic layers, which the Nordic engineers write, and the orange is the open source layers. And these 4 main repositories, those include the nRF repository, or folder. Repository is essentially another word for folder. And the 4 main repositories are nRF, nRFXlib, Zephyr, and MCU boot. So the nRF is a Nordic repository, and it does contain some of the application and connectivity protocols. nRFXlib contains peripheral drivers and stacks. Zephyr, that's where the RTOS and also some of the board configuration is hosted, and that is open source. And then MCU boot is another open source project which contains the 4 bootloaders, which contains the secure bootloader. So one of the reasons why we have 4 separate repositories is that it does provide a clean way of code separation. So if one of the repositories changes, it won't affect the other repositories necessarily. And if we go look at the figure, we can actually see connectivity. That includes things such as Thread or Zigbee. If we go to middleware, that could include, customers' custom code, Bluetooth host layers, TLS, etc. And the wireless stacks, that includes the LT link layers, 1, 2, and 3 for cellular IoT, and also the Bluetooth low energy link layer, just to name a few of them. And then you also have board configuration on the bottom to configure the board, GPIO mapping, etc. So just some of the basic, moving on to some of the basic terminology in nRF Connect SDK. Git is a lot of you are probably very well known with Git. It is an open source distributed version control system for managing source code changes. Then you have West, which is a Zephyr tool. It's essentially a command line tool for multi-repository management and also building and flashing examples. So you can easily build examples using the West build command, for example, and you can flash using West flash. A repository, I mentioned this briefly. It's essentially a version-controlled project folder. For example, nRF repository or the Zephyr repository. And every code commit creates a repository version with a unique SHA identifier. And SHA refers to secure hash algorithm, which essentially builds a unique hash value using a cryptographic hash algorithm. So you're essentially, every code commit creates a unique identifier, essentially, a unique value. Moving on to the tag, that essentially just points to a specific commit SHA identifier, and that is immutable. It doesn't change. So for this nRF Connect SDK, the tag is version 1.4. That's what Krzysztof and Joakim will talk about. And a tag does essentially give a human-readable version reference. So instead of referring to just this random commit identifier, we can refer to a tag such as version 1.4. And for tags, Nordic product development support is available, and I'll explain that a bit later. Moving on to the master branch, that essentially points to the most recent commit SHA. So that is mutable, and that's always changing. So it's always pointing essentially to the latest commit. And the master branch is essentially there to be able to start testing newer features. So testing some of the newest features earlier on. So for example, if you're a customer and you're waiting for one of the newest features, before in the nRF5 SDK, you need to wait for, say, version 15 to be able to test. Well, now you don't need to wait for the tag, for example. You can already test some of the newest features in the master branch if you wish to do so. You don't need to wait until the tag. Essentially, the master branch, it does give you the newest features, but then the tag will have some more quality assurance. So it can be a good idea, if you want to start off with a master branch and then later on you can move to a tag. So just a quick slide on development versus production support. So features that are supported for development, They can, of course, be used for development, but they're not recommended for volume production. Technical support is available on DevZone. Some of the reported bugs may not be resolved until production support. Some of the implementation may be partial, so it won't necessarily be a full implementation yet. The APIs could also change going to production, and the verification is most likely incomplete. So it's very suitable for prototype and development. Whereas features that are supported for production are maintained, and they're also suitable for product development. Again, technical support is available there on DevZone. Some of the reported critical bugs will be resolved in the master and also the latest tag version of nRF Connect SDK. And for now, the latest tag version is 1.4.0, just to give an example of that. The implementations are complete, and it's also verified for product development. So that is very suitable for integration in end products. So just a quick slide on the documentation. So here's a quick link to the documentation. And on the left-hand side of the documentation screen, you can see this on the top, and you can also see this tab on the bottom. So if you basically click on this arrow, it will expand to this, and then you can see all of the different tagged releases. So you can see right now we're on 1.4.0, 1.4.9.9, that actually points to the master branch. And here you can also click on some of the other tags. So if you're using 1.3.1, you can click on this, and then you can go to the documentation for the 1.3.1 tag of nRF Connect SDK. And likewise here you can actually expand this bar, and then you can switch to the documentation between the 4 different repositories. So whether that be the nRF Connect SDK, 1.4.0 documentation, or the nRF xlib, Zephyr, or MCU boot. Managing source code and configurations. Just a quick intro to this. So here you have the nRF Connect SDK, the code base. You might want to add your code too. That then becomes the entire code base. Then you can configure the features via kconfig. So that's how you set up feature configuration. So your application 1 might have GPS support, for example. Application 2 might have, let's say, Bluetooth low energy support, etc. So there you can easily set up the different features of the different applications. And this you can easily do via changing the kconfig file. And then last but not least, you configure the target via the device tree. So that's with the DTS file. And that then changes the, the pin mapping for each of the different devices, whether you're, for example, using a Thingy91 or a nRF52 dev kit or another reference design. So basically what these tools allow you to do, they allow you to build multiple applications for multiple boards from one code base without porting or changing any of the program code. So you can do a lot just by changing the kconfig, for example. You can change a lot of the different features. So a quick slide on release cycles. So there are regular releases on a quarterly basis. So we just had version 1.4.0. So the next release can be expected in roughly 3 months' time. It is publicly hosted on GitHub. There you can go see, look at the different tags and also the master branch. And then you can clone the nRF Connect SDK to your own computer. The fixes are released as needed, as you can see down here. Fix. So this could be 1.0.1, for example, and this could be 1.0.2. This could be version 1.4.0, and then you might have a minor tag 1.4.1. So basically the major tags, they contain a lot of them, major updates. Minor tags will contain some more minor updates. And then, like I said, the master branch essentially points to the latest commit. Like I said, fixes are released as needed, and there are long-term supported releases can have fixes applied and delivered after new releases. And last but not least, The version control management is done with Git. So that is for managing new versions and also fixing adoption. And the tool does support merging too. So just a brief update. So for the nRF52 series, you do have the option of going either via the nRF5 SDK or the nRF Connect SDK. The nRF5 SDK is very good if you do not require an RTOS, or also if you're used to this SDK and do not require newer features after Bluetooth 5.0, for example, Bluetooth Mesh 1.0.1, Thread 1.1, or Zigbee 3.0, release 22. nRF Connect SDK, like I mentioned, it's optional. It will support newer features after Bluetooth 5.0. So Bluetooth Mesh 1.0, Thread 1.1, and Zigbee 3.0. So if you need these newer features, you need to use the nRF Connect SDK. Otherwise, you can use the nRF5 SDK if you have all of the features you need inside the nRF5 SDK. And you can also see some more documentation, or you can actually look at a webinar from last May, which gives more of an in-depth intro to nRF Connect SDK. So it is slightly outdated, but a lot of the terminology is still up to date. And the nRF52 series, some of the supported SDKs, that includes the nRF5 SDK, nRF5 SDK for Bluetooth Mesh, nRF5 SDK for Thread Zigbee, and also the nRF Connect SDK. So that is all from my part, and I'll hand it over to Krzysztof for the short range update.
Hello, my name is Krzysztof. I am a member of Product Management Group, and today I would like to present what new exciting functionalities in short-range wireless area we have released for you in NCS 1.4. Let's start with Bluetooth. When you develop a Bluetooth Low Energy application, you must include a Bluetooth LE controller. A Bluetooth LE controller is the layer of the Bluetooth stack that handles the physical layer packets and all associated timing. It implements the link layer, which is the low-level real-time protocol that controls the Bluetooth LE communication. The nRF Connect SDK contains two implementations of a Bluetooth LE controller: the soft device controller and Zephyr Bluetooth LE controller. In previous releases of NCS, Nordic's Bluetooth LE controller was called nRF Bluetooth LE controller and now is renamed to soft device controller. It is possible to select either Bluetooth LE controller for application development. However, the soft device controller is now the default controller for Bluetooth samples. So why to use the soft device controller? Firstly, the soft device controller provides the same implementation of the link layer that is available as part of Nordic Semiconductor's soft devices. The main reason behind the name change was to emphasize that fact. This link layer has been used in hundreds of millions of products available on the market, and as a result ensures great interoperability. Secondly, the soft device controller supports an extensive standard feature set from the Bluetooth 5.2 specification and a number of extensions for high performance applications like low latency packet mode, and those functionalities are not available in Zephyr Bluetooth LE controller. In NCS 1.3.1, we qualified the soft device controller as Bluetooth Core Specification version 5.2 qualified controller subsystem, and in NCS 1.4 we inherit the same qualification. The improvement we made is that now it is possible to reduce the image size when linking the final binary. Now with a proper configuration of a linker file, only the requested features are included. We also added few useful Bluetooth services and samples. GATT Bond Management Service allows you to configure your desired feature set of bond management operations. For example, to delete the bond of the requesting device or delete all bonds on the server. To demonstrate how to use those functionalities, we provide peripheral bond management service sample. To facilitate radio physical layer testing, we provide direct test mode sample, which enables testing radio parameters like transmission power, receiver sensitivity, or modulation characteristics. The central heart rate monitor with coded PHY offers similar functionality to the Bluetooth central heart rate monitor sample from Zephyr. However, this sample specifically looks for peripherals heart rate monitors using LE-coded PHY to ensure long-range operation. What is interesting, these samples were contributed by one of our customers. This is possible thanks to our new development approach, in which we develop most of our SDK components on public GitHub repositories and anyone can contribute. One of the most exciting new functionalities in NCS 1.4 is support for Alexa gadgets. Alexa gadgets are Bluetooth connected, interactive companion devices that work with Amazon Echo devices. When a product is built with the Alexa Gadgets Toolkit technology, a customer can use Alexa, which is Amazon's cloud-based voice service, to interact with that product via a custom skill. The voice command is received by an Echo device and processed in the Amazon cloud. That command is then returned to the Echo device, which in turn forwards this directive to the Alexa gadget. The wireless connectivity between an Echo device and the Alexa gadget is enabled by Bluetooth. To make it simpler for you, we provide the Alexa gadget's peripheral sample, which demonstrates how a Bluetooth LE device can connect to an Amazon Echo device using the Alexa gadget's Bluetooth service and profile. In Bluetooth mesh area, we were mainly focused to improve the two topmost layers by adding more mesh models and new samples. We added time models, which allow network-wide time and date synchronization. We added light CTL models, which enable remote control and configuration of CTLs on a mesh device. So CTL, or color tunable light, is a capability of some lights that allows color temperature to be controlled via two dimensions, lightness and color temperature. We also added scene models, which allow storing the model state of the entire mesh network as a scene, which can be recalled at a later time. Bluetooth mesh scenes define entire collections of settings for an environment, optimizing it for a particular purpose. For example, you could choose to define a scene that puts a room into the perfect state for a presentation. We also added support for mesh device properties version 2.0, which add environmental sensor types like rainfall sensor or wind direction sensor. We greatly expanded support for thread networking protocol within NCS. Now Thread is supported for production for nRF 52 family, and we enabled Thread 1.1 certification by inheritance. So certification of Thread functionalities within your device is a simple paperwork. We also transferred support for multi-protocol operation with Bluetooth Low Energy from nRF 5 SDK for Thread and Zigbee to enable multi-protocol use cases required by some ecosystems like Project Connected Home over IP. To try it out, you use exactly the same samples as for single file operation. This is just a matter of a sample configuration. We have an initial support for Thread 1.2, which is a future revision of Thread protocol. And we plan to add more complete support for Thread 1.2 in the upcoming releases of NCS. Finally, we added support for network coprocessor architecture, but I will tell more about it in one of the following slides. So far within NCS, we still have for development support for Zigbee, which is suitable for evaluation and prototyping, but we added few useful functionalities. Similarly to Thread, we added support for multi-protocol operation with Bluetooth LE, and again, to try it out, you use exactly the same samples as for single file operation, but you have to configure them properly. We added support for over-the-air device firmware update for nRF 52840 and provided Zigbee command line interface, which is especially useful for evaluation and verification. And last but not least, we added support for network coprocessor architecture for Zigbee as well. And now it's time to say more about what it is. The coprocessor designs can be used when device requires additional functionalities or compute power not present in Nordic SoCs, but a more powerful processor does not have a suitable radio interface. Split stack architectures are most commonly used to design Thread border routers or Zigbee gateways, but sometimes also for complex end devices. In these designs, a more powerful host processor, which is typically Cortex-A class processor, interacts with Thread or Zigbee network through the connectivity SoC, which is Nordic SoC with 802.15.4 radio. A popular coprocessor design is the network coprocessor architecture, or in short, NCP. In case of Zigbee, the host processor runs the Zigbee application layer, ZCL, and the user application. The connectivity SoC runs the NCP application, which contains lower parts of the Zigbee stack. In case of Thread, which does not define an application layer and which is application layer agnostic, the connectivity SoC runs NCP application, which includes the entire Thread stack. The host processor usually provides an integration with host processor IPv6 subsystem. The host processor communicates with the connectivity SoC via a serial interface using a serialization protocol. The newest addition to our short-range portfolio is nRF 5340, which is a dual-core SoC. The application processor is optimized for performance and allows you to perform time-critical application tasks without being affected by radio stack execution. The network processor is optimized for low power and efficiency and is responsible for radio operations. This SoC is still in engineering phase, but we are preparing to transfer it to production. And one of important functionalities we added is device firmware update for the network core. In NCS 1.4, we added network core bootloader sample, which implements an immutable first stage bootloader that has the capability to update the firmware on the network core. This functionality is available by default if an nRF 53 sample is configured to include MCU boot, which is a bootloader running on the application core. Another very useful feature needed for nRF 5340, but also useful in a broader scope, is remote procedure call library called nRF RPC. The nRF RPC library allows for calling a function on a remote processor from a local processor in both synchronous and asynchronous way. It is designed to be used with an underlying transport layer like OpenAMP, which enables inter-processor communication on Nordic Semiconductor's SoCs like nRF 5340. Depending on the transport layer, the remote processor is not limited to a single device. It can also be a separate device of any type, for example, a PC, or another processor on the same system. NCS 1.4 adds sample which use nRF RPC to share entropy between cores. In future, this library can be used to serialize APIs of the Bluetooth Valley host, which runs on the network core, and someone would like to use those APIs in the application core. That's all when it comes to short range part. Now let's look into new functionalities in long range. Thank you.
Okay, then it's time for the cellular IoT update. So I will start by providing an overview of the most relevant components for cellular connectivity and our 9160 system in package. Then I will move on over to the updates specifically for nRF Connect SDK version 1.4.0. Starting from the bottom, we have the modem firmware running on the modem core. The modem firmware is provided as a closed source precompiled image that you can download from nordicsemi.com. The modem firmware is handling all the necessary layers up to and including TLS and DTLS. In addition to this, the modem firmware is also handling the GPS functionality. The modem core is using IPC and a shared memory to talk to the application core. Then, on the other side, we have the BSD library on the application core. The Berkeley Software Distribution Library, or BSD library, is our implementation of the well-known socket API, which is a set of standard function calls that can be used for writing applications connecting to internet. Our library aims to be compatible with the BSD socket standard to simplify your writing and porting of existing applications. The BSD library is the primary interface for operating our modem and is used to establish LTM, narrowband IoT, and GPS connections. The library abstracts away the details on memory management and synchronization, allowing you to focus on writing your applications using a standardized set of API calls. In addition to the 8 generic sockets for UDP, TCP, TLS, DTLS, and 80 commands, the BSD library supports 10 PDN sockets, 1 GPS and assisted GPS socket, and a socket for updating the modem. Building on top of the generic BSD sockets, we have the protocol stacks like HTTP, MQTT, lightweight machine-to-machine, and co-op, which are used to talk to various services out on the internet. The protocol stacks are located in the Zephyr project, but are automatically included when you download nRF Connect SDK. The SDK itself provides a wide range of examples using the stacks, and there are also some examples in the Zephyr project that can be used as a starting point. The LTE link controller library, which is intended to be used for simpler control of the cellular connections on a 9160 system in package. Some of the properties that can be configured are the LTE mode, selecting between narrowband IoT and LTM, APN and PDN configurations, enabling and disabling of GPS, power saving modes like PSM or EDRX, and these kinds of parameters. The AT command library, on the other hand, is actually a set of multiple libraries to ease usage of AT commands from the application side. It includes functionality for sending, receiving, parsing, notifications, and also sharing AT command sockets between multiple threads. Then we have the GPS driver, making it easy for the application to use the modem side GPS functionality. And we also have a DFU target library providing a common interface for device firmware upgrades across multiple partitions. Building on top of all of this, we have a wide range of libraries that is aiming to make application development even easier. Here you can see some examples of the libraries that aim to make things like cloud and internet connectivity easier, location and GPS, and also modem control. The modem key management library, as an example, provides functionality to manage the credentials stored on the 9160 modem. The library uses AT commands to add, update, delete credentials. Then, on top of all of these libraries, we provide application and examples showing you how to use the various libraries. Here you can see some of these examples. I recommend that you go into nRF Connect SDK documentation to take a closer look on the details of each of these examples. Now that we have a better overview over the components in an nRF Connect SDK that is relevant for cellular IoT, we can dig deeper into the particular updates in nRF Connect SDK version 1.4. When it comes to device management, the latest release includes an updated carrier lightweight machine-to-machine library. It has reduced memory footprint and a lower power consumption. This carrier library is mandatory to include in certain cellular networks like AT&T and Verizon. These are carrier requirements to ensure modem bug fix capabilities in the networks. The updated library is mainly for development of product that is going to be deployed in these networks and is currently not certified yet and is in the process of being certified. You can find the compatibility matrix showing which versions of this library is certified for which networks on our Nordic info center. When it comes to device management, we have also improved the lightweight machine-to-machine client example. We have added support for bootstrapping. We have added modem and application core firmware over-the-air updates. And we have also added a configuration overlay that is fine-tuning co-op and lightweight machine-to-machine parameters for the protocol stacks to work more efficiently with narrowband IoT networks. Moving over to the cloud platform support, we have added a Microsoft Azure library talking to Azure IoT Hub using MQTT. The Azure IoT Hub library supports functionality like device provisioning service or DPS. This is for onboarding and registering new devices. It supports the device twin for long-running commands intended to put the device into a certain desired state. Could, for example, be set the telemetry send interval to 30 minutes or similar. It supports messages, both device to cloud and cloud to device. These are intended for one-way notifications to both the device and the cloud. The library also supports direct method which is intended for communications that require immediate confirmation of the result. Direct methods are often used for interactive control of devices, such as turning on a fan and so on. The Futal Azure library is using the device twin to receive firmware upgrade information and then HTTPS to download the image before applying the update. Both the nRF 9160 system in package, the nRF 9160 DK, and the Thingy 91 is now also to be found listed on the Microsoft Azure Certified Device Catalog. Then we have some new features making it simpler to achieve low current consumption. The LTE link controller has gotten an API for easy configuration of the EDRX paging window, or PTW, previously having to be set through 80 commands. It has also gotten support for setting the release assistance indication, or RAI, used to release the RRC connection as soon as the application is finished sending data on narrowband IoT. We have also added a power-optimized UDP sample, where we enable easy configuration of the necessary parameters to reach lowest possible power consumption. This example is intended to be used together with the online power profiler. And we have also updated the online power profiler to support configuration of 3 extra network parameters that we see are varying a lot in the different networks around the globe. These parameters have quite a high impact on the power consumption of the device. If you head over to Nordic Dev Zone, you can find the online power profiler for LTE, and you can see the various parameters you can adjust. Here you can set things like the LTE mode, choosing between LTE M1 or narrowband IoT. You can enable and disable power saving modes. You can enable and disable EDRX intervals. You can set up how big your data payload is, how often you send data, and here are the network parameters that have been updated now. You can set the on duration in connected DRX, inactivity timer, and also the repetitions. And if we scroll up here, middle of the screen, we can see the estimated power consumption in this particular use case. Here we get the total average current, the PSM floor current, and how much energy is consumed in the LTE events. Then we have the serial LTE modem, or SLM for short. It is an application example that is used in scenarios where, for various reasons, you want to use the 9160 system in a package as a legacy standalone modem. The SLM application exposes a set of 80 commands over the UART interface so that any external application processor can use this interface to set up sockets, use the protocol stacks like HTTP, MQTT, CoAP, and more, control the modem and GPS and all kinds of functionality that's needed on an external application. nRF Connect SDK version 1.4 adds TLS server support to this example, support for MQTT username and password. It adds a new pass-through data mode between the server and the client. It has a new HTTP client and firmware update over there possibilities. Together with nRF Connect SDK version 1.4, we have also released a new version of our modem. It's called version 1.2.2. This release mainly focuses on GPS improvements. For instance, it adds a new low accuracy mode that greatly improves time to first fix. It has improved overall GPS hot start sensitivity and have improvements on time to first fix when the device have poor signal conditions in cases like urban canyons or other scenarios where parts of the sky is somehow blocked. Version 1.2.2 also adds TCP server support and have a long list of various stability and performance improving changes. For the full list, you should go over to nordicsemi.com and download the latest release zip, and there you can find all the release notes. Then, last slide, that's just a summary of the new features and updates we have in our SDK. Then it's time to answer some questions.